Hi, my name is Theo Stainby, and I am a junior electrical and computer engineering major here at Grove City College. I'm really excited to tell you about our ongoing work on the Ant Robot Research Project. We're designing a robot that will be able to follow and track ants as they move throughout their natural environments. This semester, the Electrical Engineering Department teamed up with the Computer Science Department here at Grove City College. This created a team of multidisciplinary student researchers. Our work this semester has given us a baseline as to how well we can track an ant as it moves through its environment. We selected 2 algorithms to implement and then test. The 2 algorithms which we decided on were an insect-inspired tracker known as IIT and a kernelized correlation filter approach known as KCF.
KCF is different from some of the other algorithms we looked at in that it focuses on how the object in the bounding box appears. It basically looks for exactly an image fit of what it began with and moves on from that step by step. We used a MATLAB implementation and then ran it offline on some of our ants data set. And we found that KCF performed fairly poorly.
In most of the videos, actually, it just predicted where the ant started throughout the whole video.
We think that KCF performed poorly for a couple of reasons. One of the big reasons is that the frame rate was fairly low, and so when the robot would move, the ant would be in a drastically different spot in the frame from the previous frame. Another issue that we considered is that because our video is fairly low resolution, that the ant only has a couple of pixels in the entire video that represent it, and so KCF doesn't have a lot of data to work with to define what the ant was in one frame to go into the next frame. Sometimes having higher resolution or more information actually makes feature extraction more difficult, but this is something that we want to play around with.
The insect-inspired tracking algorithm works by modeling a dragonfly's biological vision system. It applies a collection of visual filters onto each frame of the video, thereby reducing each frame into something that can be easier analyzed and modified by the computer.
We looked into IIT because of its performance on a data set that seemed to match the conditions that we had. That was small objects in natural scenery rather than having ants on a white background or something with high contrast.
The insect-inspired tracking algorithm unfortunately did not perform very well. We believe this is due to a low frame rate in the video samples we acquired, although there may be other factors involved.
So in the end, neither of our algorithms beat the baseline in terms of their accuracy. We suspect that this is likely due to a low refresh rate from the robot's camera, as well as a lack of detail in the resolution of each image. To fix this problem next semester, we would like to add a Raspberry Pi to the robot. This will allow us to offload computer vision tasks to the Raspberry Pi's processor, which should allow us to achieve a higher frame rate as well as higher resolution images. Stay tuned next semester as we continue our exciting work on the Ant Robot Research Project.